This video is going to cover section 4.8 regarding implicit differentiation, but first I want you guys to do a little warm-up, just practice with differentiation. So go ahead and pause the video, work on these problems for about 5 minutes, and then come back to the video and check your answers. So number one, you were asked to derive 5x times sine of 2x cubed. So here we have the product rule, and then we also have the chain rule to worry about. So 2d1 plus 1d2. So 5 sine of 2x cubed plus 5x times 6x squared, that's the derivative of the inside, times cosine of 2x cubed. If I were to simplify this, just combine my 5x, 6x squared, I get 30x cubed for that combined part. And for number two, given f of x equals negative 6x to the fourth times e to the 3x squared minus pi, evaluate f prime of x. So we have product rule once again, and then don't forget about your chain rule. So the derivative of the first is negative 24x to the third times e to the 3x squared minus pi. And then I'm going to add that 2, keep my first function the same. The derivative of the second part is 6x and then times e to the 3x squared minus pi. Remember, the derivative of pi is just going to be 0 since that's a constant. And then if I were to simplify this down just a little bit, it would turn into negative 24x cubed e to all that minus 36x to the fifth times e to that power. So this next section is called implicit differentiation. So just to kind of let you know what implicit versus explicit means is that all the equations that we've been differentiating have been of the form y equals or f of x equals. And this is called an explicit form because it's explicitly written for y, but not all equations are going to be written like that. You might get an equation that looks like this: xy squared plus x cubed y equals 6. And in this case, we can't get y by itself because there are two different powers of y. There's a y squared and then just a y to the first, and we can't get y by itself. So we have to use something called implicit differentiation. And so here are the couple of steps that it takes, and then I'm going to walk through a few examples. So the first step is that you want to differentiate both sides of the equation with respect to x. And remember to obey the chain rule by multiplying by dy dx or y prime for each expression containing y. We kind of did this when I was teaching you guys exponential differentiation when we were trying to find the derivative of y to a power. And when we had to do the derivative of the y side, we had to also do y prime or dy dx. You can use either notation. After you have differentiated both sides, you want to make sure you isolate all the dy dx's or y primes on one side, and then factor if necessary to solve. And so those are the only two steps. I think walking through the examples will help clarify what these two steps mean. So the first example I have is 2xy plus y squared equals 3. And sorry I didn't write the directions down, but I want you to differentiate this equation. Okay, so the very first thing I'm going to do with my 2xy, I'm going to use product rule, and then with my y squared, that would just be 2y, and then I have to use chain rule and also multiply it by dy dx. And so this is what it looks like. So using the product rule, I have 2 times y plus 2x dy dx. dy dx is the derivative of y with respect to x. And so these first two terms is just the derivative of the 2xy. Then derive y squared and you get 2y dy dx, and then the derivative of the right side is just going to be 0. So now what I want to do is get my dy dx by itself so that I have an equation for the derivative. And so then I'm going to subtract 2y from both sides. And then on the left side I have everything that contains a dy dx, and so I'm going to factor out a dy dx. So then I'm left with dy dx times 2x plus 2y equals negative 2y. The last thing to do to get dy dx by itself is to divide by 2x plus 2y. And so our derivative, dy dx, equals negative 2y divided by 2x plus 2y. You could factor out a 2 out of the denominator and then cancel out the 2's, but you can just leave it like this as well. But you should know how to simplify this. The second example is, y to the fourth plus x cubed y to the fifth minus 2x to the seventh equals 13. So I want you to differentiate this. So the derivative of the first part is going to be my 4y cubed, and then I'm going to multiply that by y prime this time. So just remember, y prime is the same thing as dy dx. So then for y cubed y prime, this next part I have to use product rule. So I get 3x squared y to the 5th plus x cubed times 5y to the 4th times y prime. And then minus this last part, I can just derive, no product rule necessary, negative 14x to the 6th, and then the derivative of the right side is just 0. So everything that does not contain a y prime, I'm going to move over to the right side, and then those that do contain a y prime, I will eventually factor. So I've moved over my 3x squared y to the 5th, and I've moved over to the 14x to the 6th to get that right side. And now on the left side, I'm going to factor out a y prime. That leaves me with 4y cubed plus 5x cubed y to the 4th in parentheses. The last thing to get y prime by itself is to divide. And so then this is our derivative. So this is called implicit differentiation because we can't get y by itself explicitly before we do the derivative, but we can get y prime by itself at the very end. And then the last example I have is just practicing writing equations of the tangent line. And so we're going to write the equation of the tangent line to the curve at the point 1, 2 of the equation x cubed y to the 5th plus 2x equals 34. And granted, yes, we could get y by itself. In this case, we could just subtract, divide, and take the 5th root. But this will make things a little easier, and it's good practice for implicit differentiation. So we already have our x and our y value, the 1, 2. If we didn't, if I just gave you the x value, you would have to somehow find the y value. So what we need to do is find the derivative because we need the slope of the tangent line. So on the left side, using implicit differentiation, remember to use product rule on this x cubed y to the 5th. So I get 3x squared times y to the 5th plus x cubed times 5y to the 4th dy dx plus 2 equals 0. Get the dy dx on one side, bring everything over to the other. So I'm going to subtract the 2, subtract my 3x squared y to the 5th, and then the last thing I'm going to do is divide by my x cubed 5y to the 4th. So here's my derivative, but we're not done with the problem since we were asked to find the equation of the tangent line. So now what I need to do is plug in my point 1 and 2. So I'm not just plugging in my x equals, I'm also plugging in my y equals. And so this is kind of the notation for it. It's this dy dx with this vertical bar and then with a coordinate in the bottom right. And so that's just illustrating that we're evaluating the derivative at the point 1, 2. So I'm going to plug in my 1's for x's and my 2's for the y's. And I'm going to solve that. And that will get me the slope of the tangent line, which is negative 98 over 80. And you could reduce that down, or you could just leave it. And so then the last thing is to write the equation of the tangent line in point slope form. And so y minus 2 equals the negative 98 over 80 times x minus 1. I hope those 3 examples were helpful with implicit differentiation. You guys can practice on your own on the assignment on page 172. You guys are doing numbers 1 through 8. I will see you tomorrow. Have a great day.